liquids have some sort of mobility, means the particles of or the constituent of this liquid can leave their position slightly. As these particles can leave their position slightly, these substances called liquid have fixed volume but does not have definite shape. They take the shape of the container in which they are placed. Then we have this gas. Now in case of gas, the distance between the particles or the constituent of this substance are very far. As the distance between the particles are very far, the attractive force between the constituent particles are very weak. As the attractive force is weak, the constituent or the particles of this gas can move freely in all possible directions. As the particles can leave its position and move in all possible directions, these class of substance called gas does not have fixed shape. They do have a fixed volume but does not have fixed shape. That means if you place a gas in a container, the gas will occupy all the whole volume. So this is the basic difference between solid, liquid and gas. So basically differences between the distance between the constituent particles. As the distance varies, attractive forces varies and their shape volume also varies. Now coming forward to this gas, as the distance between the particles are very large, they can be easily compressed. So when we talk of the compressibility factor or gases can be highly compressed, whereas in case of solid, the distance between the particles is very close to each other. As the distance between the particles is very close to each other and they are held together by very strong force, the compressibility factor for this gas solid is very poor, or simply we can say these are not compressible. Whereas liquid, which is in between solid and gas, they can be easily compressed, but their compressibility is less compared to that of gas. So when we talk of the compressibility, gases are highly compressible, liquids are compressible, but their compressibility is less than that of gas, whereas solids, the compressibility factor is extremely poor or small. Now, this solid, liquid and gas, solids, the diffusibility of solid is extremely poor. Liquids do have diffusibility. Diffusion is intermission property. Whereas in case of gas, gas can be easily diffused. Solids are very rigid. Rigid means they have a fixed volume and they have a fixed shape because of the strong attractive force between the constituents. So solids are rigid. When we say these solids are rigid, their melting point should be very high. Liquids, rigidity is there, but rigidity is less compared to that of solid. So since the rigidity is less in case of solid, the melting point of the liquids will be less compared to that of the solid. Whereas in case of gas, gas are very less rigid. So this is a basic difference between the solid, liquid and gas. Now, the next we have is plasma state. Look at this. This plasma state is that particular state of matter in which the gases are taken to be taken at very high temperature. So we have gas. These gases are taken at very high temperature. So at this high temperature, these gas molecules undergoes ionization and is converted into gas ion and the free electrons. So these particular state of gas at very high temperature, when they are converted into gas ions and the free electrons, that is known as the plasma state. And the last one is Bose-Einstein Condensate. The Bose-Einstein condensate is just opposite of the plasma state. That is, in this Bose-Einstein condensates, we have supercooled gas. The supercooled gas is known as Bose-Einstein condensate. So this is a rough classification of the matter based on their physical state. Now, once we know this differentiation between solid, liquid, gas, plasma, and Bose-Einstein condensate, now we move on to the chemical classification of matter. So, based on these chemical properties of matter, matter is classified into two types. We have pure substance and mixture or impure substance. So based on chemical properties of substance, matter is classified into two categories, pure substance and mixture. Now, these pure substance is further subclassified into two elements and compounds. Mixture is again of two types. One is known as homogeneous mixture. The other one is known as heterogeneous mixture. So, based on chemical properties, we have two types of matter, pure substance and impure substance or mixture. Pure substance is further classified into elements and compounds, and then we have mixture. Mixture is classified again into homogeneous and heterogeneous mixture. Now, coming to this pure substance, let's see what is the meaning of elements and what is the meaning of compounds. Now, we have a term elements. Elements are pure substance. Now, elements, the basic definition of elements is those substance which contains only one type of particles, that is atoms. Contains only one type of atoms. So elements are those substance which contains only one type of atoms. So if the particular substance contains only one type of atom, then we say those are known as elements. So look at this example of elements. We have look at this sodium metal. So sodium metal contains only the atoms of sodium, no other atom. If along with this sodium, some other atoms are also present, then we cannot say this is to element. So when we say or when we talk of the element sodium, so element sodium contains only the atoms of sodium. We can have copper. So copper is an element because copper contains only the atoms of copper. We can have carbon. So carbon again contains only the atoms of carbon. So these category of substance which contains only one type of atoms is known as elements. Then we have compounds. So if element contains only one type of atom, then compound should have at least minimum two different types of atom. So compound is formed by combination of two or more than two types of atom. So those substance containing two or more than two types of atoms are known as compounds. So this contains two or more than two different types of atoms. Those substances containing two or more than two different types of atoms are known as compounds. We have looked at this example H2O. So H2O contains the atoms of hydrogen and the atoms of oxygen. So we have two different types of atoms. So we classify this water as H2O as a compound. We can have look at this CaCO3 calcium carbonate or limestone. So these calcium carbonate contains atoms of calcium, atoms of carbon and atoms of oxygen, and these atoms are combined in a fixed ratio. So these type of substance are known as compounds. So element contains only one type of atom, whereas compounds contain minimum two or more than two different types of atom. So these are classified as pure substance. So in these compounds, we have two or more than two different types of atoms. So before combining to form this class of substance known as compounds, the atoms will have some property, but after combination of these atoms to form compounds, the individual atoms loses their identity. Whereas in case of elements, the individual atoms retains their identity. So in case of compounds, these atoms have certain property before combination. After combination, these atoms loses their individual property. So we have these elements and compounds. Now in between these two, sometimes we also use the term molecules. So let's see what is molecule. We have molecules also. Now look at this. We say it's simply H2O molecule. You also say H2 is a compound. Then what is the basic difference between these molecules and the compounds? So when we talk of the term molecule, so molecule means or signifies or identifies the smallest unit of a substance or a matter which has got its independent existence, and that basic unit or the smallest unit can be used to define all the properties of the substance. Those basic units or the smallest unit of matter is what we call as molecules. So I repeat the definition. Molecules are defined as the smallest unit of a substance called matter which has independent existence and which can be used to explain all the properties of substance called matter. So this is the smallest unit, and this smallest unit has independent existence and this smallest unit retains the properties of the matter or can be used for explanation of the properties of matter. So that basic or smallest unit which has its independent existence and which can be used to explain all the properties of substance called matter is what we call as molecules. So now look at this. When we say okay, water is a compound, why we say water is a compound? Because according to the definition of compound should have minimum two different types of atom. So in case of water we have hydrogen and oxygen. So we have two different types of atom. So we say this is compound. Now we have what we simply say H2O is also molecule. We say example is H2 is a molecule. Now if I say H2 is a molecule, H2 is a compound, then let's see what is the difference between these two. So when I say H2 is a molecule, that means we have a substance, we have a metal called water. We have a substance or we have a metal called water, and the smallest unit of that particular substance called water is H2O, and this H2O has its independent existence, and this H2O molecule, whatever may be the property of this H2O molecule, that is a property of the substance called water. So the properties of water can be explained by use of this smallest independent existing part, that is H2O. So we have a substance called water, and for this substance the smallest independent existing unit is H2O, and this smallest unit can be used to define all the properties of that particular substance called water. So if I say water, so normally we say water means H2O, but that is actually wrong. Why? Because method is a combination of millions and millions of these H2O units. So that assembly is what we call as water, and in that water the smallest existing unit is H2O, and this H2O is used to explain the basic properties of the substance called water. Similarly, we say CO2, carbon dioxide molecule. So we have a substance called carbon dioxide. We have a method called carbon dioxide, and in that method the smallest independent existing unit is CO2 unit, and this smallest independent existing unit CO2 is known as the molecule, and the properties of that particular substance called carbon dioxide is basically the properties of this CO2. So this is the difference between molecules and the compounds. We can also look at this helium molecule. Helium molecule. Yeah. Now, coming to look at this, we also say look at this element. Simply we can say look at this helium is an element. So look at it. Helium is also element. Helium is also molecule. Now again look at this. Then what is the difference between this molecule and element? So element definition says that there's only one type of atom. So we have a helium gas. Helium gas contains only the atoms of helium. So helium is an element. Now according to the definition of molecule, we have a substance called helium gas, and for this helium gas, the smallest independent existing unit is He, helium, He. So this smallest independent existing unit, which is used to explain all the properties of the substance called helium, that is He. So this is also molecule. Now, so looking at this example, it's pretty much clear. These molecules may be elements or may be compounds, but all elements cannot be molecules because this H2 is not an element. Molecules may be compounds, but all compounds will not be molecules because definition of compound says that it should have two different types of atom, but we have molecules, helium, neon, argon. These are monoatomic gas, so this contains only atoms of helium, neon or argon. So molecule is also pure substance, but basically we define pure substance in two different terms, that is elements and compounds. So this is pure substance. Now coming to mixture. So we have this mixture. So as the term suggests, mixture is a combination of two or more than two different components. So mixture contains two or more components. So this is simply a mixture of two or more than two different components in a definite or fixed ratio. That combination is what we call as mixture. Now this mixture is classified as homogeneous and heterogeneous. So now coming to Difference between these two, homogeneous and heterogeneous. Homogeneous mixture. Now, the term homo stands for same or uniform. Now, we have a mixture of, take this two components. Now, we mix these two components. After mixing of these two components, the mixture shows homogeneous distribution of the components in the mixture. That means we have a mixture of two components. After mixing these two components, the mixture forms a homogeneous mixture. Homogeneous mixture means the distribution of components in the mixture is uniform throughout. That is uniform distribution of component. So if there is uniform distribution of components in a mixture, that mixture is known as homogeneous mixture. Now, what is the meaning of uniform distribution? So uniform distribution means after mixing these two components, there is no line of demarcation or distinction between the components. Those mixture in which there is no line of demarcation or distinguishing mark between the components, that is what we call as uniform distribution or homogeneous mixture. So uniform stands for no line of demarcation between the components. So that is what we call as homogeneous mixture. That is uniform distribution of components. So we have these examples like the sugar solution. Take sugar, that is one component. Take water, that is another component. Mix these two. Sugar completely dissolved, water forming a clear transparent solution. So once sugar is dissolved in water, you cannot say okay, which part is sugar, which part is water. That compound sugar is completely dissolved in water and it forms a homogeneous mixture. Similarly, you can have salt solution. Take sodium chloride, dissolved in a given volume of solution. Sodium chloride completely goes into solution. Again, look at this. Once the salt is dissolved in water, there is no line of demarcation or distinguishing mark between salt and water. So this is homogeneous mixture. We have looked at this steel. Take the case of steel. Steel is a mixture of carbon, iron, nickel, etc. etc. So once this carbon, iron, nickel and various components mix, this mixture forms a homogeneous mixture. So in that part we cannot define which part is carbon, which part is iron, which part is nickel. So steel is a homogeneous mixture of these various components. So this is what we call as homogeneous or uniform distribution. We can have brass, we can have bronze, we can also have pure air. So take the case of pure air. So pure air contains only a mixture of gases. So when we mix the gas, there is no line of demarcation between the gaseous components. So this is what we call as homogeneous mixture. The other component is heterogeneous mixture. The second one is heterogeneous. If homo says uniform or same, hetero means different. So So in case of heterogeneous mixture, again we are taking two components. So the component after mixing does not form uniform distribution. So in case of heterogeneous mixture, that is non-uniform distribution. So if there is non-uniform distribution of the components in a mixture, that mixture is known as heterogeneous mixture. Now when we say non-uniform, so non-uniform means in the mixture there is a clear line of demarcation between the components. If there is a line of demarcation or a distinguishing mark between the components, that mixture is known as heterogeneous. So there is line of demarcation between the components. That means we can easily identify here which component is in this mixture, what is the component A and B. That type of mixture is known as heterogeneous mixture. So look at this example. Mixture of sand and sugar. So when we mix this sand and sugar, we can easily identify which part is sugar, which part is sand. This is what we call as heterogeneous mixture. So this is not a pure substance because this contains two or more than two different types of components, but they are mixed in such a way. Okay, one of the mixture may have uniform distribution, whereas there is no line of demarcation between the components. This is known as homogeneous mixture. If there is a line of demarcation or non-uniform distribution between the components, then we say this is heterogeneous. So we can say the polluted air. So polluted air is again an example of heterogeneous. So polluted air, we have different components. So these components can be easily visible. We have gas, we have smoke, we have dust particles. So dust particles and everything can be easily seen. So that is what we call as heterogeneous mixture. So this is basic classification of matter. What is matter? How matter can be classified? We have some physical properties as well as chemical properties. And under physical properties, we have 5 different categories. Under this chemical, we have 2 different, and each 2 different categories further sub-classified into 2 different forms. So we have given the definition and examples. So this is matter. Now, this matter has got some properties. So, properties of matter. So, let's see what are the basic properties of matter. Every matter has mass or weight. Now, we usually use mass and weight to be both identical or equal, but there is a basic difference between mass and weight. Mass is the amount or quantity given or present in a given substance. So that amount or quantity present in a given substance, that is what we call as mass, whereas weight is a force of gravity. Force due to gravity that acts on the given mass. So therefore this weight is equals to mass into g. G is acceleration due to gravity, so mass multiplied by this acceleration due to gravity G, that is what we call as weight. Second property, all these matter, substance called matter has got volume. Now there are different methods to measure the volume of a given substance. Like look at this example. Suppose we have a cylindrical object, or suppose we have cubical object, then for this volume is length into breadth into height. If suppose we have a spherical substance, that is volume is defined as 4 by 3 pi r cube. Or if suppose we have cylindrical type, then its volume is defined as pi r square L. So depending on the shape, we have different formula to define the volume, but each substance called matter has got some fixed volume. Then third property of this matter, they have got temperature, These matters do have density. Now we all know density is defined as mass of a given substance per unit volume. Mass of a given substance divided by volume. This ratio is defined as density. So these are the basic properties that a particular substance called matter has, or every matter possesses these properties. So this is matter, classification of matter, and the properties of matter. Once we know this matters, while defining this, we have taken into account the basic constituent. Now, then the question is, let's go to the details of the basic constituent of the matter. That is atomic theory. Which is more popularly known as Dalton's atomic theory. Because whenever one talk of atoms, we start from Dalton's atomic theory. So now look at this. This Dalton's atomic theory is given by John Dalton. So in honor of that particular scientist, this theory is given as John Dalton's atomic theory. This does not mean that these atoms were discovered by John Dalton. Even before this Dalton, the concept of atom was there. But this scientist, Dalton, was the first scientist who gave a concrete idea or concise idea about the atoms. So this theory is known as Dalton's atomic theory. Now, let's see what are the basic postulates of Dalton's atomic theory and the drawbacks or limitation of the Dalton's atomic theory. Now, the postulates of Dalton's atomic theory. So the first postulate is the building unit of substance is known as atom. So atom is the smallest. So according to Dalton's atomic theory, atoms are the smallest building units of substance which are indivisible. So he says atoms are smallest unit which is indivisible, indestructible. and smallest unit. So the first postulate given by John Dalton is atoms are the smallest unit which is indivisible. So obviously look at it, if a particle, we say okay, this is the smallest, and then that smallest can be further divided. That is the first postulate given by John Dalton. Now look at this, how far this statement is true, or say whether this statement is 100% correct or whether this statement is wrong. Now look at this. Now as the science develops, we have studied what is present inside the atom, that is structure of atom. Now in this substance, the unit of substance called atom, inside these atoms we do have electrons, we have a nucleus, inside this nucleus we have a protons, we have a neutrons. So now look at this, once we say this atoms being the smallest, there is no subatomic particle, there should not be subatomic particles, but we know inside this atom we have electrons. So if suppose inside this term atom there is another particle called electrons, so obviously electron size should be smaller than that of atom, and inside this atom we have a nucleus, and inside this nucleus again we have protons and neutrons. So obviously the size of nucleus should be smaller than the size of atoms, and inside this nucleus we have protons and neutrons, so obviously the size of neutron and proton should also be smaller than that of nucleus. Now look at this, once we say atoms consist of nucleus, inside this nucleus we have protons and neutrons, and around this nucleus we have electrons moving in circular orbit. So if this cannot be divided further, then how comes this the presence of electron, protons and neutrons inside this atom is identified? That means the drawback of this statement is there are subatomic particles. Subatomic particles, we have electron, we have proton, we have neutrons. Now the presence or the discovery of this subatomic particle whose size is smaller than that of atom, and these particles is found to present inside the atom. So the term indivisible and the smallest unit comes out to be factually wrong. So atoms cannot be the smallest unit. We have subatomic particles whose size is much smaller than that of atom. And look at again, atoms cannot be divided further. But if atoms cannot be divided further, how comes the discovery of this electron, proton and neutrons comes into picture? So the first postulate comes out to be factually wrong statement. Second statement of this Dalton's atomic theory. This theory says atoms of an element were found to be identical in properties, especially their mass. So the statement says atoms of an element, their properties are identical. Properties identical, especially mass. So obviously, if we have a particular element, so this element, according to the definition of element, contains only one type of particles, that is atom. So if a particular element contains only the elements are atoms of that element, so all the atoms of that element should be identical in their properties. Properties means physical as well as chemical properties. So if the properties are identical, obviously their masses should also be identical. That seems to be correct. Now let's see the drawback of this Second statement. So atoms of an element are identical in their properties. Drawback of this statement. Now we have a term known as isotopes. In lower class we have gone through the term isotopes. Isotopes are elements having same atomic number but different mass number, same atomic number but different mass number. Those species are known as isotopes. At the simplest case, we have hydrogen. Now this hydrogen has got three different forms. Hydrogen, atomic number 1, mass number 1, which is known as protium. Second form of hydrogen is heavy hydrogen, atomic number 1, mass number 2, that is known as deuterium. Third form of hydrogen is radioactive form, atomic number 1, mass number 3, this is known as tritium. So these are three different forms of hydrogen. So hydrogen exists in three different forms. Protium, atomic number 1, mass number 1. Deuterium, which is also known as heavy hydrogen, atomic number 1, mass number 2. Tritium, which is the radioactive form, atomic number is 1, mass number is 3. So these are hydrogen only. So these contains atoms of hydrogen. Now we have hydrogen, element hydrogen, and these elements contain the atoms of hydrogen only, but the masses are different. We have mass 1, we have mass 2, we have mass 3. But the second postulate given by Dalton says atoms of an element are identical in their properties, especially their masses. But we have this hydrogen. We have three different forms of hydrogen containing only the atoms of hydrogen, no other atoms of present other than atoms of hydrogen. So these isotopes has got different mass. So the second statement given by John Dalton regarding this atom again comes out to be factually wrong. The third statement of this Dalton's atomic theory is if the atoms of an element are identical, then atoms of different element must have different properties. So atoms of different element have different properties. So if you have different elements, obviously their properties should be different. Again, this is especially mass. So atoms of different elements will have different properties, especially their masses should be different. Again, let's see how far this statement is correct. That is the drawback of this third statement. These atoms of different element will have different atoms, and if you have a different atoms, their properties must be different, and especially their masses should also be different. Now we have a class of substance called isobars. Isobars. So we have termed this isobar. So isobars are the one having different atomic number but same mass number. Different atomic number but same mass number. If the atomic number is different, obviously we have a different atoms. So if the atomic number is different, then theory says their properties should be different. But we have a class of substance called isobar which has different atomic numbers, different atoms, but their masses are found to be same. So mass are same. But postulate number 3 says different elements, different properties, especially their masses should be different. So again look at this. Due to the discovery of this class of substance called isomer, the third statement given by Dalton's atomic theory again comes out to be actually wrong. So look at this: carbon and nitrogen. Carbon atomic number 6, nitrogen atomic number 7. So we have atoms of carbon, we have atoms of nitrogen, but we have a form of carbon whose mass is 14, and we have nitrogen which mass is 14. So we have two different atoms, that is atoms of carbon, atoms of nitrogen. These two different elements having different atoms, their masses are same. So these two substances are known as isomer. So due to the discovery of isomer, the third postulate again comes out to be the wrong statement. Next postulate of Dalton's atomic theory, that is postulate number 4. So postulate number 4 says atoms are indestructible. Indestructibility of atoms. So indestructibility of atoms means atoms can neither be created nor destroyed. Can neither be created nor destroyed. This is what called as indestructibility of atoms. Now let's verify this statement again. So atomic theory says atoms can neither be created nor destroyed. But now look at this. We have nuclear fission and we have nuclear fusion. So we have fission and we have fusion. Fission means breaking into smaller fragments. Fusion means smaller fragments combined to give you a larger part. So these are two opposite things. Fission, we have a larger part. This is fragmented into small fragments. Whereas in case of fusion, we have small fragments combined together to give you a larger component. So discovery of this fission and fusion. Fusion, we have a larger atom, and now this atom is broken into other atoms. So means we are creating the atoms. Fusion, we have other atoms due to chemical reaction. This gives you another atom. So this is what is taking place in the solid sun. So look at this, we have hydrogen combining to give you helium. So we are taking this hydrogen atom is converted into helium. That is what is taking place in sun. The reaction which is taking place in the sun, due to which enormous amount of energy is released, that is known as fusion reaction. So look at this, we are converting this hydrogen atom into helium. So we are creating atom. Now look at this, on the other side look at this, we have a nuclear fusion reaction, that is the basic principle of atom bombs. So we have, look at this, in this, look at this, we have taken a fissile uranium. Now this uranium on strike by neutron, this is converted into lead, plus some other particles are released and energy is released. So we are starting with this uranium. After this reaction, this is converted into lead. So look at this, starting with this uranium, we are getting lead plus some other products are formed. So look at this, we are destructing this uranium and is converted into lead. On the other side, we have taken hydrogen. These smaller units combined to give you helium, larger unit. So the discovery of this fission reaction and fusion reaction again proves the fourth statement given by John Dalton, that is indestructibility of atom, again comes out to be actually wrong statement. The fifth statement given by this atomic theory is whenever these atoms combine to form molecules and compounds, obviously molecules and compounds are formed by combination of atoms. So whenever these atoms combine to form molecules and compounds, the combining ratio is always simple whole number ratio. That means whenever atoms combine to form molecules and compounds, the combining atomic ratio is simple whole number ratio. Simple whole number ratio of combining atoms. So during molecule formation or during compound formation, we have different atoms combining to give you molecules and compounds. So whenever these atoms combine to form molecules and compounds, the combining atomic ratio is always found to be simple whole number ratio. Okay, we have this hydrogen oxygen, that is water. So we have 2:1 ratio. Take this, we have carbon dioxide, we have 1:2 recombining ratio, we have N2O5, we have 2:5 ratio, etc. So it seems to be whenever we have molecules and compounds, the combining atomic ratio always follows simple whole number ratio. But there is another class of compounds which does not follow this simple whole number ratio. That is, we are going to the drawbacks of this statement. There are some compounds which is known as non-stoichiometric compounds, which is also known as Berthelloids. These non-stoichiometric or these Berthelloids doesn't have simple whole number ratio, does not follow simple whole number ratio. So these class of compounds which does not follow simple whole number ratio are known as non-stoichiometric. Stoichiometry we'll discuss later on. So when we say whenever we have atoms and molecules, atoms combined to give you molecules and compound, they always combine in simple whole number ratio. Then how come this class of substance for non-stoichiometric compounds are formed? The formation of non-stoichiometric stable compounds says always simple whole number ratio is not followed. So again look at this, basically the fifth statement again comes out to be factually wrong. Take this example. We have look at this iron oxide. So look at this, the ratio is not a simple ratio. We have 0.98 part of iron combined with 1 part of oxygen. Similarly, look at this. Nickel oxide, we have 0.94:1. So the combining ratio is not simple whole number ratio. So we have this non-stoichiometric or Bartholomew compounds. So these are the basic concepts of Dalton's atomic theory and the drawbacks of this Dalton's atomic theory. So till now you are going through these are the basic postulates of Dalton's atomic theory, but no one gave you idea about whether these statements are 100% correct or wrong. But due to the development of science, discovery of science, the basic postulates given by John Dalton were found to be all wrong. incorrect. But again, then see why we are going through these incorrect statements, why we have been taught these incorrect statements in earlier class. The reason is this was the first person who gave the concise idea of atom. We are proving that these concepts are wrong only because of the development of science. Without knowing the concept of atom, how can we prove what is atom? What are the correct statements? What are the wrong statements? So whenever we talk of this atomic theory or atoms, first we discuss this Dalton's theory, and from this Dalton theory we refine atoms. So after going through this Dalton's atomic theory, we only come to the conclusion that these postulates were not 100% correct, but the basic concept given by John Dalton was used for defining atoms, and these basic concepts of Dalton's atomic theory were again used in laws of chemical combination. So this is the concept of atom, Dalton's atomic theory, limitations or drawbacks of Dalton's atomic theory. Okay, for today we are concluding here. All the best.